Imagine the grandest story ever told, the story of our universe. For centuries, humans have gazed up at the night sky, wondering about the fate of everything we see. Our curiosity has driven us to build telescopes, launch satellites, and peer deeper into the cosmos than ever before. For decades, we thought we knew how it would end. A cosmos stretching on for unimaginable eons, expanding ever outward into the unknown. Stars would burn out, galaxies would drift apart, and the universe would fade into a cold, dark void. The light from every star would eventually vanish, leaving only silence. This was the heat death, a slow, silent fading into nothingness, where energy is spread so thin that nothing new can ever happen again. The timescales were so vast, numbers with hundreds or thousands of zeros, that the end felt like forever. It was almost impossible to truly comprehend such immense stretches of time. In this vision, only black holes and dead stars would remain, floating in endless darkness, silent witnesses to a universe that once teemed with light and life. Even the most massive black holes would take a Google years, a 1 with 100 zeros, to evaporate, slowly leaking away their energy into the void. The final dissolution of the universe was thought to take 10 to the power of 1,100 years, a number so large it defies imagination. That's a timescale so long the current age of the universe is just a blink, barely a moment in the grand cosmic timeline. This was the consensus, a universe winding down, not with a bang, but with a slow fade to black, a gentle and inevitable decline. It was a lonely, almost eternal ending, a sense of cosmic permanence, where nothing new could ever arise. But science is always evolving. Our understanding of the universe is never truly complete. New discoveries can challenge even our most fundamental beliefs, forcing us to rethink what we thought we knew. What if our calculations missed something crucial? What if the universe is hiding secrets we have yet to uncover? What if the universe's final chapter is not as slow as we thought? Could the end come sooner or in a way we never expected? The cosmos, after all, is full of surprises, and the story of its ending may be far stranger than we ever imagined. Now, a new chapter has begun. Scientists from the Netherlands have re-examined the universe's end and found it may come much sooner than we believed. They didn't discover a new force, but looked closer at a process Stephen Hawking first described. By applying Hawking's idea to all dense objects, not just black holes, they found a new, faster pathway for cosmic decay. White dwarfs, the remnants of stars like our sun, will evaporate in about 10 to the power of 78 years, a dramatic shift from previous estimates. The era of dead stars will end much sooner than we thought. This doesn't threaten our sun or galaxy anytime soon, but it's a profound shift in our understanding. The universe is not as patient as we imagined. The processes leading to its demise are more efficient than we realized. Science, once again, refines our picture of the cosmos. What is this mysterious process that can make even a star disappear, leaving behind only a faint memory in the cosmos? It's called Hawking radiation, a phenomenon that challenges our understanding of the universe. To understand it, we must enter the strange and counterintuitive world of quantum mechanics, where the rules of reality are rewritten at the smallest scales. Empty space isn't truly empty. It's a restless sea of energy, where virtual particles constantly pop in and out of existence, borrowing energy from the vacuum itself for the briefest moments. Near a black hole's event horizon, the boundary beyond which nothing can return, one particle from a pair can fall in while the other escapes, becoming real and carrying away energy. That energy comes from the black hole itself, causing it to slowly lose mass and shrink, a process that continues over unimaginable timescales. Over billions, even trillions of years, even the mightiest black hole can evaporate, one quantum drop at a time, until it vanishes completely. Hawking radiation is incredibly slow, almost imperceptible, but it is relentless, never stopping, always working. It's the universe's way of ensuring that nothing, not even the most powerful objects, lasts forever. The Dutch researchers realized this process isn't limited to black holes alone, but could apply to other dense cosmic objects as well. Any object with immense gravity, like neutron stars or white dwarfs, can trigger this quantum leak, slowly radiating energy away. Their powerful gravity can separate virtual particle pairs, causing these dense remnants to lose mass over time, just like black holes. So not just black holes, but all dense objects are slowly leaking energy back into space, contributing to the gradual transformation of the cosmos. This insight changes our understanding of cosmic longevity, revealing that the universe is far more dynamic than we once believed. The universe is more dynamic and more temporary than we thought, with even the most enduring objects destined to fade. Even the most persistent objects are subject to this slow, inevitable decay, as quantum physics quietly shapes the fate of everything. Nothing escapes the reach of quantum physics. Not stars, not black holes, not even the universe itself. With this new understanding, we can estimate the lifespan of almost anything in the universe, from the smallest particles to the largest cosmic structures. The story of how things fade away is written in the very fabric of space and time. Supermassive black holes and neutron stars both take about 10 to the power of 100 years to evaporate, a Google years. These titans of the cosmos, once thought to be eternal, are actually on a slow countdown to disappearance. Surprisingly, neutron stars, though much smaller and denser than black holes, are just as persistent. Their incredible density allows them to resist decay for unimaginable stretches of time. They'll be among the last complex objects to fade away, holding on long after most other things have vanished into darkness. Less dense objects, like our moon, take even longer, up to 10 to the power of 133 years. The moon's slow journey toward oblivion is almost beyond comprehension. Our moon may outlast the giant black hole at our galaxy's center, quietly orbiting in the dark long after the Milky Way's heart has faded. Even humans, in theory, would evaporate over 10 to the power of 106 years. Our atoms, too, are subject to the slow unraveling of time. From black holes to our own bodies, everything is temporary. Nothing escapes the slow, inevitable march toward dissolution. The universe is on a long, slow journey back to energy, where all matter will eventually dissolve into a sea of particles and radiation. Every object, no matter how grand or small, is destined to fade. The cosmos itself is a story of transformation and impermanence. The laws of physics are universal and inescapable, guiding the fate of everything from galaxies to grains of dust. Everything is part of this cosmic cycle, a never-ending dance of creation, transformation, and eventual fading into the vastness of space. One of the most startling results is the cosmic race between neutron stars and black holes. We once thought black holes would outlast everything, the final survivors of the universe. But new research shows neutron stars are just as resilient. Both will evaporate over similar timescales, thanks to the extreme curvature of space-time around them. The far future will be populated by these cosmic twins, fading away in parallel. It's a beautiful symmetry. Two different stellar fates sharing the same ultimate end. This challenges our neat categories: stars, black holes, neutron stars. In the end, the universe blurs these lines, following a deeper logic. The cosmos is more unified and more elegant than we ever imagined. The universe will end sooner than we thought, but sooner is still unimaginably far away. White dwarfs will vanish in 10 to the power of 78 years, black holes and neutron stars in 10 to the power of 100 years. The current universe is just 13.8 billion years old, 10 to the power of 10. To visualize the new timeline, imagine the universe's history as a grain of sand. The future would be a pile larger than our galaxy. The difference between old and new estimates is vast, but both are beyond human comprehension. As one researcher put it, it's still a very, very, very long time. Calculating these numbers is a triumph of human curiosity. We are tiny, short-lived creatures, yet we can peer into the universe's deepest future. The headline may say the end is sooner, but it's a cause for wonder, not alarm. Our understanding grows, and the cosmic story becomes even richer. This discovery isn't just about numbers, it's about the nature of reality. The research team, led by Heino Falk, wanted to know what happens in a nearly empty universe. Their curiosity builds on the legacy of Stephen Hawking, showing that you don't need an event horizon for evaporation. Extreme gravity is enough. This subtle shift means the universe has more ways to dissolve than we thought. The process of decay is more universal, applying to a wider class of objects. The research connects general relativity and quantum mechanics, hinting at a deeper, unified theory. It's a small step toward understanding all the forces of nature. The scientists express awe and humility at peering so far into the future. The laws of physics allow us to make these predictions with confidence. The universe is not only beautiful, but surprisingly simple in its fundamental rules. By studying the end, we learn more about the beginning. Why study the end of the universe when it's so far removed from daily life? It's not about predicting doom, but understanding the cosmos at its limits. The far future is the ultimate laboratory for testing physics. Thinking about the end gives us context. Our lives are a fleeting moment in a vast cosmic drama. This isn't depressing, it's inspiring. We live in the age of stars, a brief, brilliant era filled with light and life. Research like this fuels our imagination and sense of wonder. The quest to understand our origins and destiny is deeply human. Even if practical benefits are rare, the pursuit of knowledge enriches us all. The ultimate takeaway? The universe's end is a story of impermanence and elegance. Everything from particles to black holes is on a journey. Matter and energy transforming, leaving behind a quiet, empty space. The new timeline changes the pacing, not the ending, revealing a deeper unity in nature. Neutron stars and black holes sharing a fate hints at the universe's fundamental secrets. We live in a special time, surrounded by stars and cosmic wonders. For most of the universe's life, the sky will be dark and empty. Our view is a fleeting gift. It's our privilege to appreciate, study, and understand it. The universe's story is our story. We are part of it. Our curiosity and science are the tools to piece together this grand narrative. As we learn about the universe's fate, we learn about ourselves. Temporary but magnificent witnesses to the cosmic dawn.